You'll see that the first few classes are going to be really easy, okay? Don't be under the misconception that it's going to be easy throughout, okay? I always see that people do poorly in the first exam. Your first exam is actually going to be relatively easy compared to all other exams. So you won't do very well in the first exam because remember your best exam is 20%. Okay, so this is basics of, we probably have learned these things we're going to talk about now in probably a physics class. We're talking about position, speed and velocity. So position. So a body starts from origin, it covers the distance s, then the position is given by s. This is the particle. Okay, displacement. Okay, the displacement is basically the change in position, so delta S. Okay, velocity, average velocity. Is defined as the displacement delta S divided by the time in which that displacement took place. Then find the average speed. Okay, ST is defined as the total distance covered. So example would be, if you start here, you go 5 meters in 5 seconds, okay, and then walk back again 5 meters in 5 seconds, then V average. Okay, the average velocity is, what's the average velocity? If you go 5 meters in 5 seconds and 5 meters back, the average velocity is 0 because your displacement is 0. You did not move any further, right? You just you ended in the same place where you started. However, the average speed is not 0. It's going to be, well, you covered 5 meters up, 5 meters down, so you covered 10 meters, and that was done in 5 seconds up, 5 seconds down, so 10 meters in 10 seconds, so it's going to be 10 divided by 10, which is 1. Meters per second. Okay, so that's the difference between average speed and velocity. Okay, so a few other definitions and we'll get started with problems. So it's going to be essentially concepts, problems, and that's what we'll do, and we might have in-class quizzes some point of time. Will be clear next time. So a few other definitions. Acceleration, you can write an average acceleration, which is delta v. Just like there is average speed, average velocity, average acceleration is delta v divided by delta t, and then there is instantaneous. It should be average instantaneous instantaneous velocity, speed is not the right word, and then instantaneous acceleration. So this is where we got to use calculus. V is the instantaneous velocity, it's the change in displacement versus time, so it's going to be ds dt, where d is the calculus operator, and the acceleration is dv dt. Okay, you can write v, but v is ds dt, so you can write this to be d square s dt square. Okay. Okay. And then finally, there's another way you can write acceleration. It's actually v dv ds. Okay. The difference is that the first formula which I wrote down, this one, if you're given velocity as a function of time, yes, you can differentiate velocity as a function of time, get acceleration. But sometimes you're given velocity as a function of s, in which case the second formula is useful. You see that you'll be using both formulas, and it's actually people forget the second formula which I wrote down, this v dv ds, but that's as useful as the first one, as we'll see. Okay, so let's start with problems. What I should have done is, well, I'll do this in the next classes. I'll actually post all these notes like you see it now, without anything written down, on Blackboard. So you can download them and take a hard copy or put it on your tablet and write. So you don't have to copy these questions. Okay, so I've not done this for today's class, but I will do it from next class. So bear with me. A particle moves along a straight line with a velocity of 4t minus 3t square meters per second, where t is in seconds. You're given that when time t equals 0, s is equal 0. So to find the acceleration as a function of time, position is a function of time, and position when the time is 1 second. Okay, so let's get started. So first, find the acceleration as a function of time. You're given, well, what's the formula for acceleration? It's simply dv dt. Is d dt of, the velocity is given, it's 4t minus 3t square. So that's going to be 4 minus, you're expected to know simple differentiation like this. You will not be given the formula. So derivative of 4t is 4. The derivative of 3t square is, well, the derivative of t square is 2t. So the answer is 4 minus 6t. So you have to find the position as a function of time. Okay, how will you get the position? Integrate, right? So if velocity is, the definition of velocity is, it's the change of displacement, which is 4t minus 3t square. So we can integrate this. Ts equals 4t minus 3t square. Going to integrate this. dt. Right, I took this dt to the other side. Okay, so there are two ways to do this integral. One is as an indefinite integral like this. You integrate, you'll have a constant of integration which you evaluate based on the initial condition that t equals 0, s equals 0. Or you can do the definite integral, which is you just put the limits and you're done. So I prefer the second one because we'll see we do a lot of things and it's just easier to do it instead of trying to have a constant of integration and then sub in. So what I do is I put some information, something I know about the system. I know that at time t equals 0, the position is 0 as given here. So I need to find the position s when the time t is t, some t. So to integrate this, integral of ds is just s. Integral of t is t squared divided by 2. Expected to know this. And then integral of t square is t cubed divided by 3. And then I need to sub in the limits. So upper limit is t, lower limit is 0. Essentially the lower limit equates to 0, so this will give me 2t squared minus t cubed, and so the expression for the displacement is 2t squared minus t cubed. Okay, and the final question is find the position when t equals 1 second. So third part, find the position when t equals 1 second. It's simply substituting 1 in the expression for s. So 2 times 1 square minus 1 cube equals 1. The units are in meters, so this should be 1 meter. Okay, any questions? Okay, next question. Okay, a particle is moving with a velocity of v0 when s equals 0 and t equals 0. If it is subjected to a deceleration of a equals minus kv cubed, where k is a constant, find velocity as a function of time and distance traveled when velocity is reduced to half of its initial value. So velocity becomes v divided by 2. So let's do it one at a time. Let's do one first. Okay, so first question, we asked to find velocity as a function of time. Okay, that's the question. So we know the acceleration, it is minus kvq. Okay, since we want velocity as a function of time, I would sub in the value for acceleration, which gives me velocity as a function of time, which is dv dt, and then try to integrate so that I'll get v as a function of t. So minus k, well, I need to move things around. So I can write dt equals minus dv divided by kvq. Right? I just moved this down and dt up with the negative sign. So dt equals minus, pulling the k out, and then there is the integral here. Okay, so the time t goes from 0 all the way to t, initial velocity. So when time t equals 0, we're going to sub in the corresponding value for the velocity. So you're given that when st equals 0 here, velocity is v0. So I'm going to write v0 here. We'll just write 0 here. And then the final velocity v, which is the unknown, right? So write it this way. This integral, the left side is just simply t. The integral of 1 divided by v raised to 3 is, well, you're going to write this as, let me just write it here. I would write this as v minus 3 dv. Okay, and the integral of v raised to minus 3 is v raised to minus 3 plus 1 divided by minus 3 plus 1. That's the formula for integral of v raised to n. It will be v raised to n plus 1 divided by n plus 1. The limits are v and v0. So minus 2 divided by minus 2 minus v raised to v0 minus 2 divided by minus 2. Okay, so I can simplify this expression and write velocity as v0. So I skipped a couple of steps. I just wrote the final answer. Okay, next question asks you find the distance traveled when velocity is reduced to half. This should be v0 by 2. So you have to find the distance traveled when velocity is v0 divided by 2. You're also given that s equals 0, the velocity is v0. Okay, so the difference between this and the earlier question, part 1, is that in the first part you asked to find velocity as a function of time. Here you are asked to find, in a way, velocity as a function of displacement, s. So if you use the same formula, dv dt, then it's not going to be helpful because v is a function of time. In this case, we want v as a function of s. So this is where you use the other formula I was talking about, which is acceleration is v dv ds. Okay, so you can see there's time s here, and that will help us to find s when the velocity reduces by a factor of half. So the acceleration is minus kv cube e dv ds So I can cancel a v from either side, and I'm left with I'm going to move things around, so I'll get minus k ds equals dv divided by v square, and I also need to take the integral from in this case s goes from 0 all the way to s. The velocity changes from v0 to v0 divided by 2. So this is minus 1 over v. Okay, again you have to do v minus 2, so minus 2 plus 1 divided by minus 2 plus 1, which is minus 1 upon v, v0 divided by 2, and v0. So this gives me minus ks equals plus 2 divided by v. So it will be 4, 2, and so to simplify this, okay, the distance is 1 divided by k dg. Any questions?